Hello everyone, welcome back to my channel. So in this video we'll see the construction of Routh array. Okay, construction of Routh array, and then we'll solve one or two examples on this. Okay, if you are first time to my channel, please consider subscribing and encourage me to do more videos like this. So construction of Routh array, let us take a simple we know that, so in the previous video I have explained you that we are taking the characteristic equation, that is 1 plus g of s into h of s is equal to 0. Okay, so this is called as characteristic equation of closed loop system. Okay, closed loop system, right? So using this characteristic equation we are going to solve, we are going to comment on stability using RH criterion. Okay, so suppose take a simple example of a third order characteristic equation like a naught s cube plus a1 s square plus a2s plus a3 is equal to 0. So this is a simple characteristic equation of order 3. Okay, so here what you have to do is we have to construct the Routh array. So construction of Routh array is like this. So take the highest power of the characteristic equation. So here in this example, so highest power is 3, so highest power of s, so highest power of s you have to take. Okay, so highest power of s. Okay, so you are taking highest power of s, which is s cube here, right, and write its corresponding coefficient a naught. Since it is an odd power, 3 is an odd number and it is an odd power, so write all the corresponding coefficient of odd powers of s. Okay, so odd powers of s includes s cube and s, so s coefficient, so you have to write only coefficient value. Okay, so this is how the first row is constructed. So first row consists of the highest power. If it is odd power, if the given highest power is odd, write all the odd coefficients here. If the highest power is even, write all the even coefficients here. Okay, right. So then s square, so decrement the power of s by 1, so then s square, so s square its corresponding coefficient is a1. Since it is an even row, write all the even coefficients, even coefficients is a3 also, because 0 is also an even number, so this can be written as s power 0. So 0 is also an even number, so you can write here. So s1, the next coefficient. So for the next coefficient what you have to do is you have to multiply these two elements, that is a1 and a2, and multiply these two elements a0 and a3, subtract a1 a2 from a0 a3, that is a1 a2 minus a0 a3 divided by a1, divided by this term you have to take. Okay, since there is no other terms, we'll stop here. So if you have another term, you can have to perform again. Right, s power 0 is this term multiplied by this term, same procedure. So if you can take 0 here, 0 multiplied by a1 divided by this total term, so that is a1 a2 minus a1 a2 minus a0 a3 divided by a1, this multiplied by a3 minus 0 into a1 divided by a1 a2 minus a0 a3 by a1. So 0 into a1 is 0, so you'll get this part becomes 0, so this and this gets cancelled out, so you'll get only a3 here. Okay, so you'll get only a3. Okay, so this is the completion of Routh array. Okay, so just have to multiply the diagonal elements Okay, so from left to right first, and then from right to left, and then subtract between them and divided by the first element. Okay, so let us see for order 4. So a0 s to the power of 4 plus a1 s cube plus a2 s square plus a3 s plus a4 is equal to 0. Okay, so these a1, a2, a3 are real coefficients. It may be either negative or positive. Okay, a1, a2, a3, a4 and a0, all these are real coefficients. Real coefficients. It may be either negative or it may be positive, but they should be real in nature. Right. So as I have told you, the highest power is even here, so s to the power of 4. So first of all, write all the even powers. So here even powers are a0, next is a2, and next is a4, because here you can write it as s power 0, so 0 is also an even term, so you can write like this. Next is s cube. S cube is an odd power, so write all the odd powers, two odd powers, a1 and a3. So a1 and a3 are the odd powers here, a1 and a3. Okay, so this is how first two rows can be written. Right, so if the highest power is even, write all the even coefficients. If the highest power is odd, so in the next row, if the highest power is odd, write all the odd coefficients. Next, s square. S square, as I have told you, this multiplied by this and this multiplied by this divided by a1. So that means a1 a2 minus a0 a3 divided by a1. Okay, so you can write 0 here. If there is no coefficient, you can write 0 coefficient. And then next multiplication is a0 with a4 and 0 with a2. Okay, so this is the coefficient. So a0 with a4 and a0 with a4 okay, sorry, so then a1 a4 a1 a4 minus 0 into a0 divided by a1. Okay, so 0 into a0 is 0, so a1 a4 by a1 gets cancelled off, so you'll get only a4 here. The leftover coefficient is a4. Okay, so this is, I'll write it in brackets, so leftover coefficient is a4 only. Right, next s power 1. S power 1 same, so this multiplied by this and a4 multiplied by a1 divided by this. So a1 a2 minus a0 a3 divided by a1, this multiplied by a3 minus a4 into a1 a4 divided by a1 a2 minus a0 a3 divided by a1. Okay, this is the thing. And since for the next, this is multiplied by 0 and this is also multiplied by 0, so 0 into 0, everything becomes 0, so we don't have to write it. So s power 0 is obtained by multiplying this total term with a4 divided by this total term. Okay, so divided by this total term, that is the only thing left out. So when you divide this by, when you multiply this by a4 and divide it by same, so you'll get only a4, so that will be the Routh array. Okay, so this is how we can construct the Routh array. Okay, so don't worry about this, you'll understand clearly when I solve some problems. Okay, so as I have to tell you the procedure, I'm telling you with the coefficients here, but when I solve problems, you'll understand very clearly. Okay, so we have seen the construction of Routh array. Okay, so this is what Routh array we have got. So RH criterion to comment on stability depends on the coefficients of first column. coefficients of first column in our Routh array. Okay, so these are the first column coefficients. So these are the coefficients of first column. So you will get some values for a0, a1, depending on either a0 is positive or negative. So you'll get some positive and negative terms, maybe all positive, maybe some positive and negative. Okay, so based on that coefficients, whether they are positive or negative, so we can comment on the stability using RH criterion. Okay, so I'll write the two important points. So after construction of Routh array, the conditions for stability are okay, so first point, if all the coefficients in the first column of Routh array are having same sign. I'm not telling you that it should have positive sign or negative sign. It should have same sign, or having same sign, and no coefficient in first column. The first column are 0, so no coefficient should be 0. That is, all these coefficients should not be zeros. And if they are having same sign, then we can say that system is stable. And all poles lies in the left half of S-plane. Okay, so if these coefficients are all having same signs with all non-zero values, then we can say that this system is stable. So we know that when the system is stable, then all the poles lies in the left half of S-plane. Okay, so that is the condition here. So all the coefficients must have same sign, and they should not, and all should be non-zero terms. Okay, second, if any sign change occurs in the first column of Routh array, then the system is unstable. And the number of sign changes represents the number of poles in the right half of S-plane. Number of poles in the right half of S-plane. Okay, so if there are sign changes here in the first column of the Routh array, then the system is said to be unstable, and number of sign changes represents the number of poles in the right half of S-plane. When there are poles in the right half of S-plane, we know that the system is unstable. Okay, so it purely depends on the first column of the Routh array. Okay, so coefficients of the first column of the Routh array. What is sign change? Sign change means changing from plus to minus or from minus to plus. If the coefficients are changing from a positive value to negative value or from negative value to positive value, is said to be a sign change. Okay, so if the coefficient value is changing from plus to minus or from minus to plus, then it is said to be a sign change. Okay, so we'll save problems, then you'll understand very clearly. Okay, so we'll see two of these problems. Okay, so we'll solve using Routh array RH criterion. Okay, so we'll first construct Routh array and solve using RH criterion principle. Right, so the highest power here is 4. Okay, so I'm taking S4 row, so the coefficient of S power 4 is 1, and the next even coefficient is 3, because S square is the next even power of S, so its coefficient is corresponding coefficient is 3, and next coefficient is 2. Okay, right, so S power 4, S3 and 2 here. Next S cube, which is an odd power of row, so odd power row 2 and 1 here, so 2 1. Right, next is S square row. Okay, decrease by 1, so decrease by 1 each power. Okay, power of S is decreased by 1. So next row is like this, 2 into 3, 6 minus 1, 6 minus 1 is 5 divided by 2, 2 3s are 6, so this is 2 into 3 6, 1 minus 1 into 1 is 1, 6 minus 1 is 5 divided by 2. So you can write 0 here, so next coefficient will be 2 into 2 minus 1 into 0 divided by 2. So 2 into 2 is 4, 4 by 2, 4 by 2, which is equal to 2 you'll get. Okay, 4 by 2, which is equal to 2. S power 1, S power 1 is again, so this multiplied by 5 by 2 multiplied by 1, 5 by 2 multiplied by 1 minus 2 into 2. So 5 by 2 into 1 is 5 by 2, minus 2 into 2 is 4 divided by 5 by 2. Okay, so this becomes 5 minus 8, which is 5 minus 8 is 3, 3 by 2, so it will be minus 3 by 5, minus 3 by 5. So this coefficient is minus 3 by 5, and anyhow the remaining is 0. S power 0 is minus 3 by 5 into 2 divided by minus 3 by 5. Only term left over is this into 2 into 0 into this, so you don't have anything. So minus 3 by 5 minus 3 by 5 gets cancelled, so you'll get 2 here. Okay, so I'll write clearly so that you can understand easily. So 1 3 2, this is what we have got, S cube. So this is for your understanding purpose only. Okay, so 2 1, S square, S square, what you have got is 5 by 2, we have got 5 by 2, and this is 2. S power 1, S power 1 we have got it as minus 3 by 5, and this is 0 anyhow. S power 0 we have got it as 2. Okay, so this is the construction of Routh array. Okay, so by practice you don't have to write like this, you can write directly like this. Okay, so by practice you can write like this, no problem. Right, if you observe the first column of Routh array, so this is the first column of Routh array. Okay, so if you observe the first column of Routh array, this is positive, positive, no sign change. This is also positive, but this is negative. So positive to negative. So positive to negative, one sign change here. Okay, this is said to be one sign change. And again negative to positive, negative to positive, and there is another sign change. Okay, so totally how many sign changes? 2 sign changes. 2 sign changes is occurred in the first column of the Routh array. That means system is unstable. If there is a sign change in the first column of the Routh array, then the system is said to be unstable, and number of poles in right half of S plane, right half of S plane. So number of poles in the right half of S plane is 2, because number of sign changes represents the number of poles in the right half of S plane. So here number of sign changes is 2, so it represents the number of poles in the right half of S plane. So total number of poles for the system is 4, yes or no? So for a quadratic equation of of order 4, there will be 4 roots, that is 4 poles totally. So if 2 poles lies in the right half of S plane, then remaining 2 poles lies in the left half of S plane, left half of S plane. Okay, so this is how we can find the location of poles using RH criterion, and we can comment on stability. So it is one of the stability analysis technique. Okay, right, now we'll solve the second question. So S power 4, s power 4, so 1 here, then 3 and then 1. S square, sorry, s cube is 2 and 2. S power 2, so 2 3 is a 6, 6 minus 2 4, 4 by 2 is 2. I'm writing directly, okay. And then next 2 into 1, 2, 0 into 1 is 0, so 2 ones are 2 divided by 2, which is equal to 1, right. So s power 1, s power 1 is 2 into 2, 4, 4 minus 2, 2 divided by 2, which is equal to 1. And similarly 2 into 0, so this is 2 into 0 and 0 into 2, so totally it will become 0 only. So you'll have only one element. S power 0, 1 into 1, 0 into 2, 1 into 1 minus 0 into 2 divided by 1, so 1 by 1 you'll get 1, okay. So if you observe in the first column of Routh array, all are positive, all are positive terms only, so no sign changes, no sign changes in first column of Routh array, no sign changes in first column of Routh array. So when there are no sign changes, system is stable. So this system is a stable system. The system which with this characteristic equation is a stable system. Therefore, when the system is stable, how many poles will be there? So this is of order 4. So this is a quadratic equation of order 4. So all four poles lies in the left half of S plane. All the 4 poles lies in the left half of S plane only, okay. So this is how we can find the Routh array, and based on the coefficients, okay, whether they are positive or negative, we can find the pole location and comment on stability, okay.